All right, guys, so the last step. So we've dealt with parts, we've dealt with assemblies, we've dealt with presentations. Now we have to deal with drawing files. And drawing files are most important step in the whole process because that is the actual files that you create that would be handed off to fabricators to create the parts and to put together the product in which you're trying to create. And in this case, because we started with our 3D cube puzzle, as you've learned now that we can't do an assembly without parts, we can't do a presentation without an assembly, and now we can't do drawings of our assemblies, of our presentation, and of our parts without those being complete. And again, the nice part about this software is that at any time during the design process, I decide to modify a part. It doesn't matter where that part shows up, as long as you change things in the actual part file, that item will be updated in your assembly. It'll be updated in your drawing files, your presentation file. So, and that's the parametric part of this whole program. And what that means is that at any given time during the design process, you can make changes to dimensional constraints of various parts, and it'll automatically update itself all the way through the process. And that's what's so powerful about the program. You're never in a situation where, oh, you know what, I made that part too big, I have to modify it. You're never in a situation where you have to reassemble it or redo your presentation drawing or redo a drawing file, because again, if you follow the proper steps and have everything stored in a project file folder and you make the modifications to the part itself and not make a modification to the part within an assembly or within a presentation, then everything will update itself. There's not any real extra work other than going into the original part drawing and making adjustments to the original sketch and updating the extrusions, right? So again, so the next part in our process is drawing files. So like we always do, we go up to our new. We're going to go to our English because we've been working with our 3D cube puzzle in inches. And again, you'll be working with your architectural birdhouse project in inches. And then I'm going to go down and I'm going to pick the icon here that says ANSI inch IDW. And I want to pick this one, right, versus a drawing file, because this creates what's is a drawing file, which is a file for AutoCAD. We will be using AutoCAD at some point to create drawing files for our actual CNC work for tool pathing. If, again, you guys work your butts off and get to a point where you can actually prototype your birdhouse that you're working on. But it's important that some people pick this by mistake. We want to use the ANSI inch IDW. And it shows what, in the icon, what refers to as orthographic projections and drawings for our work. So I'm just going to click on that. When it opens up, you'll see that I have like a title block sheet. Okay. Again, the setup's the same as any other drawing we've been working with, whether it be a part assembly or a presentation. We have a work area, which is our drawing sheet right now. And we still have a bunch of information over here, which is our project browser, that we can work through. Now, I have provided on D2L in the content under Unit 6, there are 3 tutorials that I'm going to ask you guys to watch yourself as well. I'm going to show you today how to create a sheet, a drawing file for a part, one of the parts. Because I have to go over how to properly space them on the page, not only from the border, from the edges of the page, but from the views from one another, how to change the scale of the views, so on and so forth, and how to dimension properly. When we do our drawing files for this little project and this task, and when you move forward into your birdhouse, the part file is the file that will have the majority of the dimensions provided on that drawing. When we do a assembled view drawing, that drawing is really there just for more presentation purposes, and maybe we can show a couple overall dimensions, but we really don't get too much into putting too many dimensions on an assembly drawing, which is more presentation wise, and we don't get into doing any dimensioning on exploded view drawings or a presentation drawing. The part drawings are where you have to put all the relevant dimensions required for the part. in order to build it. Just like when I give you something to model, that drawing I gave you, whether it was the corner bracket, the flange support, the step bushing, whatever it was, that drawing came with a series of dimensions on it. And only those dimensions required to build that part were provided on that. So it's about providing all the necessary dimensions, but also about not providing duplicate dimensions and dimensions that are not needed, that are just going to clutter the drawing and confuse things. So that's what I'm going to kind of go through today with respect to a part drawing. There's a lesson on how to create the information in the title block, which I'm going to show you this morning as well. And then there's 2 lessons on how to do an assembly drawing and how to do an exploded view drawing. So I'm not going to get into that stuff. I'm just going to show you guys how to do a part. You can watch the tutorial videos on your own and then go about creating those drawings when you're ready. So if I want to change, for instance, the information, so when I talk about the title block, so a drawing sheet consists of a border, which is this border around the edge of the paper, and we have what is called our title block. You'll see that in our work here, up in our project browser, we have a default border. So that is the border itself. We don't have to worry about doing anything with that. I personally, I guess if I right click on it, the only thing we can really do is delete it. And then we have what says ANSI large, and you'll see how it's kind of shaded in blue. And that represents, that's our little title block down here in the corner. The title block is important that we fill that title block with information that's pertinent to the project that we're building. So I'm going to get to that. Let me just zoom in on it here a little bit. So the program will automatically default and select your actual login information for the drawn by. So who's the author of this drawing? I would like that every sheet that you do, and you'll be doing 5 in total again, you're going to be doing an assembled view, an exploded view, and 3 part drawings. Pick any 3 of the parts of the 3D cube that you want to do, and you're going to do a part drawing for those particular parts that you choose. I'd like you to modify this and change it to your full name. I don't want your login information. I want your full name. Who authored this particular drawing? You don't have to worry about the date because it will default to today's date based on the computer. The title is something that you want to obviously give it a title, right? Whether it's 3D Cube Puzzle, My 3D Cube Puzzle, Crazy 3, whatever you want to call it. But the key thing is in the title, every single sheet, and so when I'm evaluating your work, every single sheet that you produce, all 5 sheets, whatever the title is needs to be consistent on all 5 sheets. It needs to be the same because it's the same project. So the title of the project's not going to change from sheet to sheet. It's going to be the same with your architectural birdhouse. If you decide to do a modern style architecture birdhouse, then it's probably going to say modern architectural birdhouse, right? Or whatever style of architecture. Some people just get lazy and just say birdhouse. They don't give it a unique title, unique to yourself, unique to the actual project itself. And again, that needs to be on all sheets. And then the only other thing that gets changed is where it says drawing number down here. So we'll learn, and you'll learn from the videos that you'll have your assembly. So it's just the cube assembled with various views of it labeled. And in drawing number, it'll simply say assembled view. Done. When we do our exploded view, which is a camera shot of your presentation animation when it's all pulled apart, the drawing number on that particular sheet will be called exploded view. You'll learn when we do exploded views, you'll be creating the view itself. You'll be creating what's called a parts list, and you'll be using reference bubbles to label each of the parts that cross-reference to not only the parts list that you generate quick and easily in the software on your drawing, but when you do part number 9, for instance, you select part number 9 as one of the parts that you're going to do a drawing file for. Drawing number, it needs to relate. So it needs to say part number 9 in the drawing number. Because you'll have a little arrowhead with a bubble with a number in it that points to part number 9 on your exploded view drawing. You'll have a part number 9 listed in your parts list on your exploded view drawing. And I need to be able to look at that part, and it says, okay, that's part number 9 on your drawing for your part, and I need to be able to go and look at the exploded view and connect the dots. It needs to be the same part. Again, people get lazy, they don't name the part properly, and it doesn't match up with the exploded view in the parts list and the labeling on that exploded view drawing. So as you go through this process, you got to be very careful to kind of follow those rules when you're setting this up. To set this up, you got this little plus sign here that I can click on, and you'll get a field text. So I'm going to right click on field text, and I'm going to edit that field text. So I want to edit what's in this title block right now. Right now, what I want to do is I want to get to an option up here that is iProperties. But right now it's kind of watermarked. It's not available. I can't select it right now. So what I have to do on the drop-down menu is I have to select Properties Drawing. Once I select that, you'll notice that now the iProperties becomes available to me. When I click on that, it now offers a summary of the project, really just about the type of file, what it opens with, right? When I go to summary, this is where I can start entering some information pertinent to the project, right? Under the author, it says Lupus D, right? So I would want to fill in my full name. Now, a key thing with anything that you do in either architecture or mechanical drafting, whatever it may be, all of your written work, your text, is all in capitals. You'll notice in my title block, the title block labels are all capitals, right? It's a convention, it's a drafting convention that's been around forever, since Leonardo da Vinci was drafting, right? Things were done in all capitals because it is professional and clean and very readable, right? So you want to make sure that when we get into drawing files and you start to type text, that you just put on the caps lock key, and again, you type in your full name. The nice part too is that I can't tell you how many times I get a project handed in and the student forgets to capitalize the first letter of their name, right? That's just lazy and it's careless and it's not acceptable in this type of drawing, right? So all caps solves everything for you. You don't have to worry about shifting and capitalizing things. You just type away. And under the title is where I would put in 3D cube puzzle, right? Or whatever you want to name it. Eventually, when you design something that's personal to yourself, the product that you're designing has a unique name to it. And one would hope it has a unique name to it. 3D cube puzzle, in my case, not a unique name. And then I'll go over to my project. And this is where I have the ability. So it's a bit confusing. Just know that under the drawing number is where you put, is what part number is. So that's where you're going to put the part number. So, you know, I'm just going to say I'm going to do part number 2. That's all I have to do in terms of modifying this title block. I go in, I put my full name in, I change the title, and then I go and I change the part number. And again, every single sheet that you do, whether it's this project or your architectural birdhouse, your name gets changed on every single sheet. The date is the date, you don't worry about it. The title will be the same on every single sheet that you do. And the only thing that you necessarily have to change, or that you have to change from drawing to drawing, is the actual drawing number. If I hit apply and close this, you'll notice now that the information has been updated in my title block. I just hit OK. And now I'm ready to start working on this particular drawing. Okay? So I can go up here and I can kind of zoom all, go back to my main screen. And the first thing I have to do, and it's pretty much similar to when you created your assembly, right, is I have to place now a base view. So in orthographic drawings, we have a series of views. And again, this is the importance when I talked about back when we were creating parts about orienting your parts so that when if the front view is the front view, that's what you want to be looking at in your part. That view cube, I talked about setting the face, so if it's the front, setting it as the front view. Because your base views and projected views are exactly that. And you want to be able to say that, okay, this is my front view, this is my top view, this is my left side view, and this is my isometric view. So the process, very similar. I'm going to go up and I'm going to go and I want to put a base view in. Select a document. Now in your case, it's most likely going to default to your project folder. I don't have an active project folder going on right now. I'm actually just going to use somebody's in the class's project right now to demonstrate this. If nothing comes up in the file, then you just browse for it. And then I'm going to go and I got to go to my class folder, 3D cube, right? And let's just go to Sydney's here. 3D cube puzzle, there's hers. And I said I'm doing part 2. So I'm going to open up part 2. You'll see now it brings part 2 into my drawing. And it's showing me that it's bringing in, right now as per that cube, it's showing the front view. Is that the front view in this particular case? No, it's the top view. So again, if it's not the right view that you want it to be, then again, you can rotate things around in your view cube that comes up to provide whatever view you want it to have, right? So we're just going to leave this one for now. Then you'll notice while I'm still in this command, I have the opportunity from my base view to do what are called orthographic projected views. So when I project up, it's going to create my next view, which in this case, it's going to interpret this as being my top view. And then I can project over to the side, and this will then project what it believes to be a side view. Okay, so if you look at this, if that was my first view, and I'm looking at my view cube, well then the side view that I just did right now would be my right side view. And the view that I just projected up would be my top view. And again, if I went over here, I could project another view over this way, and so on and so forth. But for the purpose of this most orthographic projections, and you'll see them in the classroom on the examples on the bulletin boards around the class, all I expect from you is for you to have 3 projected views, whatever they may be, and they're usually a front view, top view, and a side view. And then if I drag up on an angle, I will create my 3D view or an isometric view. Once all those particular views are put into my sheet, I just have to right click and hit OK. And now it places my views on my sheet. Are they placed very well? Not really. Could they be scaled a little bit larger so that they're not so small to look at, which will make my whole dimensioning process a lot easier? Yes. So how do we do this? Right? Well, I could have done that. I could have adjusted the scale while I was placing the parts. Or I just simply quickly place my parts, and now I can go, for instance, go to my base view, and you'll see when I bring my cursor over the base view, I get a dotted red border around it. If I right click and I go edit view, it now brings me back into here where I can make changes to this. And this is where I can say, you know what, if I go scale 1 to 1, maybe I want to go twice the size. So I'm going to go 2 to 1. Looks good to me. I'll hit OK. And you see what happens? So I don't have to change the scale of my projected views because they're connected to my base view. And a projection basically is that you just kind of extend the lines of the object to create the next view of that object. So it automatically has to increase the scale of the projected views because the projected views are drafted and designed based on your base view, which is our, in this case, the computer's interpretation of our front view. That to me in terms of the size of the view, and again, it will work for all of you because you'll all be using a similar size sheet. A 2-to-1 for your part drawings will be a really good scale to work with when we're placing this. Now, we need to space out our views so that we not only allow enough room to provide dimensions that we need on our views, and we also don't want it to be crowding a border. So I wouldn't take this and drag it down so that it's like super close to the border, because I have no way to add any labeling to this. I can't label my views. I can't put any dimensions that are, it's too crowded. So I always say, you know what, you try to space things out where, when I'm working with this, try to visualize. Do I have roughly the same amount of distance from this to this, from the bottom to this, or when I decide now that I want to space this out, right? I want to kind of space things out so we have some room and they're nice and neat. And my main thing that I'm always looking for when I'm evaluating this work, and again, if the distance between the bottom of this isn't quite the same here, because by the time I try to create the same amount of space from the side, from the bottom, then it crowds all this, which doesn't work. The main thing is that whatever space I have between these two views, I want to have the same amount of space roughly. And again, I'm not asking you to measure it. I'm just asking you to eyeball it in a way where you're kind of roughly the same distance apart. So the spacing between the views need to be close. Again, I don't want to see work where something's way over here and this is way up in the corner, right? It's jammed up against things, too close to the title block, no room to put dimensions, no room to label things. So you do your best to, before you even start putting a single dimension on here, you do your best to kind of space things out so that you have some room and some consistency. I can do the same with my isometric view. So I got to right click, and you'll notice it's a separate view. It didn't change, right? Because it doesn't rely on the data from the projections from the base view. It's just relying on the three-dimensional data that is embedded within the base view itself. So I have to change that view to its own scale. So my scale, again, I can go to 2-to-1 if I want, which looks to me to be fairly reasonable. You could experiment with other views. What does 3-to-1 look like? You know what? Maybe I like 3-to-1 because it's a nice, big, isometric, three-dimensional view of it. And again, you can go, if 3-to-1 is a little too big, but 2-to-1 was a little bit too small, I could say 2.5. And the other thing is you'll notice right now it shows up as the color of the part. And this is the presentation, the important part of our drawing file for a part. Our projected views, so our two-dimensional views, our base view, and our front view, top view, side view. We do not want those views to be in color. We want to see the different line types, and we don't want to see any color in those because those are our drawings, our two-dimensional drawings. But the isometric view, we want, for a presentation purpose, we want it to be in color. You guys would have had a really hard time putting together that 3D cube puzzle if I didn't provide you with drawing files that had the assembled view, the exploded view, and part files that had specific colors associated with them. Because if I just gave you, and I'll just kind of move this, and again, this isometric view I kind of want to put up in this corner, and again, I don't want it jammed up against the side, right? So if I just hit OK right now, if I gave you a bunch of drawings like that, and your exploded view drawing had no color to it, and your assembled view had no color to it, it'd be impossible for you to solve the puzzle. So if I go back here again, and I right-click on it, and I go to my edit view, I want to change this to what's called a shaded view. That's going to import and bring in the color properties of the part that you created. So we have a hidden line view. We have a hidden line removed view, and I'll get to that when I talk about the line work and this stuff. And then you have the shaded view. So all I'm going to do is click on shaded view, hit OK. And now I bring the color into the drawing. So I've set up my title block. This is my part 2. I brought in the base view based on the part. I did my projected views and I did my isometric view all at the same time. I adjusted the scale of things. And now I'm ready to add the most important information, and that's my dimensions and my labels. Key things to understand and to look at in these drawings is that object lines. We have different types of lines in our work. And there's 3 major lines when we're doing drawing files. We have object lines. So the outline, anything that is in our view of the drawing is called an object line, things that we can see. And they're often a darker line. So if I kind of zoom in here, right, the outside, these lines are all object lines. You'll see that they're darker than this particular line type, which is a dashed, and it's a lighter line type in terms of the thickness of the line, and that's called a hidden line. What that's doing is it's showing some sort of feature of the design that you cannot see in this view. That could represent a hole going through the part. It could represent all kinds of different things, right? This particular view, which is actually in this particular part, the top view, there's nothing hidden. But as I project and I go to the top view of this particular thing, well, this element is what represents this dashed line. I now no longer can see this element, but it's there, right? And that's what's nice about the software is that it does all of this line work for you. Back in my day when I was taking drafting in high school on a drafting table, I had to draw all this stuff. I had to use specific line weight. I had to turn my pencil in a certain way and use a certain type of lead in order to create these different types of lines. The software now is just fantastic. I don't have to worry because everything is clean, consistent on every drawing that you do, and it's just taking the information from the part to create what you're trying to create on this particular drawing file. Last thing we have to do, and the only other line type is a center line type. So if I have like a hole going through something and I have to dimension and label it, I would put center lines to it, and then that would then create a different type of line type. But in this particular project, in your birdhouse, you're going to have things that are cylindrical in nature. You're obviously going to have a hole in your birdhouse for the bird to get into it. And most birdhouse holes are circular in nature, if not all of them. And you'll have elements of design where you'll incorporate that third line type, which is a center line. Last thing we have to do now is we have to annotate or add our dimensions and add our labeling. So up in our tabs after place views, we have our annotate tab. And again, everything looks very familiar to what we've been doing all along in terms of how we do things. The dimension tool looks the same as when you're actually doing sketches and creating parts, right? So when I go to my dimension tool now, I'm going to start adding dimensions to my various parts, right? What I'll say is try to avoid adding any dimensions below the parts. Add it off to the sides and on top, but try to avoid if you can at the bottom. But you may not be able to avoid it depending on the details of the feature. Because we want to at least, though, if we have to do some stuff below, we need to at least add some detail or leave some room to add our labeling of our views. So I always look at, okay, I'm dimensioning things first based on their overall dimensions. So I can provide an overall dimension on this view by clicking my 2 little green dots and dragging up my dimension. You'll notice as you drag up, it kind of snaps at various spots. So it's just kind of going off and doing its thing. So overall, so we always start with our overall. So I'm going to go there, and I'm just going to drag it up to there, for instance. When this pops up, it'll say edit dimension when created. Okay. If you don't want to be completely annoyed every single time you put a dimension in, you need to uncheck this edit dimension when created. And then that won't happen again. So now I've created my overall dimension for this particular part. We do not dimension 2 hidden lines on a view. So I wouldn't dimension from this corner to this endpoint of that dimension line. I'll provide that information somewhere else. We're only dimensioning to objects, lines, or our solid lines. The next thing I want to do is I'm going to now do my second level of dimensioning of this part, and I'm going to do from here to here. And again, I'm going to drag it up where, it's pretty much the midpoint of that other dimension line. And then I'm going to do this section and drag it up like that. And you'll notice how it snaps in where my two arrowheads are perfectly together. Don't be lazy, and I don't want, again, you'll lose marks on your drawing files if I see something where you've put the next dimension there because you're just trying to rush to get it done. Okay? The object is to make very neat, clean, professional drawings, and this is not neat, clean, and professional. Your dimension lines should never cross other dimension lines, so I would never do something like this. So whatever lines I do, I just have to do that and make sure that my lines line up. Now, saying that, I didn't have to put in that dimension for 1. If my overall is 3, and I just did a dimension that says it's 2, why would I waste my time putting that dimension of 1 in there? Because it's given. If it's 3 and that is 2, then all that's left over is 1. So I don't have to put that dimension in. So I'll also be looking at kind of the efficiency of the dimensioning that you're doing. Making sure that you're not putting more than, like, once I put this overall dimension of 3 in my object on this view, because it's a projected view, that means that I don't have to put the overall width on this view. It's up here. This view has been projected and created by this view, so this has no choice other than to be 3 inches wide overall. So I don't have to waste my time putting another dimension on this, showing the overall and showing all of the other stuff. It's the same here. I don't have to put a dimension on this of 2, right? And technically, if I want, I don't even have to put 1 on this, right? I don't even have to put a single dimension on this top part of this view. Now, if I click on that, I gotta get out of the. If you want to get out, just hit escape. If I want to delete this, I just click on it, hit my delete button. So there's a couple dimensions there. And then I'll do the same, for instance, on the side of this view. So I'm going to do my overall, drag it out. And again, I'm going to drag it out to the same that I dragged this one out. I'm not going to drag this thing out way further or way shorter. And then I got to add in my details again, right? So maybe I'm just going to do this detail and bring it to about the midpoint. That's all I need to do. So when I look at this particular part, I've got all the information on that view that I need for this particular part. And then you just kind of go through this same convention and you go and you add dimensions where, again, you can't necessarily assume. Now, I can't assume on this view, for instance, that this is 3 inches, right? Because this is a projected view from this. So the only time we can assume that dimensions are the same are the dimensions on the projected view. Because this view has been created from this view, and this view has been created from this view. So if I say that this is 3, that means that this is 3, but the projection that this width has been created by this projection, so I cannot make that same assumption for the height here. So this is where I'd go in on this particular part, on this view here, and I would add my, and you'll see how that line popped up, so it shows me it's the same distance away. And then I would do, and again, I don't have to just pick the endpoints. I could simply just pick the line. Hold on a second here. Choose my line, drag it out, pick my line, drag it out. Keep hitting that for some reason. And that's that. Again, I didn't have to add that last one. So it's about being efficient and only provide the information that you need on the drawing. So I'm not going to go through and I'm not going to label everything, right? And again, so over here, if this projected view says that this is 3 inches high, I don't have to put an overall of 3 on this projected view of this side. It's already there for me. I don't dimension to this hidden line. All I'm doing is I'm just providing, but I cannot, again, assume what the overall length of this part is. So I would have to, in this situation, do my dimension where I have my overall and one of these added to it. So on and so forth. And you know what? And as I did this, I'm like, oh, you know what? This looks pretty crowded now. So I can escape that. I can go back to my place views. And I can kind of drag this out a little bit more. And the last step on this, and again, what I've done here isn't 100% complete. I may be missing some dimensions that are needed to fully make this part. Like if I gave this drawing to you right now and said to model the part in Inventor, you might not be able to do it. And the last thing under annotate that you want to do is label the actual views. And I'm going to go just simply by text. So there's a text under the annotate tool. I'm going to pick a location. So we're always putting our text below the view. So I just click with my left click. And what you want to make sure you do is, and it's like with any, you could change the font if you want. I just go with the Tahoma here because it's the same font that's used everywhere else, right? I'm going to want to change my text to 0.24 because that's the biggest text that we can do. I mean, you can modify, you could change that too, but it's a good size to read properly. And in this particular view, I know that this is my top view. So I'm just going to type in top view, hit OK, and now I've got my top view labeled. I'll go click down here again, make sure I change it to 0.24, and this is my front view. Then I go over here. And again, it doesn't default back, so you have to change the font size. And this would be my right side view. And then up here, I'm going to put in another, and this is my isometric view. And I got to make sure, see now, I jumped ahead. So if I realize, oh, shoot, I messed it up, I didn't change, I just have to highlight it in the text box, go to my 0.24, hit OK, and now I'm all labeled. Hit OK. And the other last thing that we want to do is I want to make sure that my label is roughly the same distance below my view from the nearest object line. So if I look from my top view to this and from my front view to that, they're pretty close. And I want the view to be centered on the view. Easy to do on this view because I have an object that's broken up into threes. So I just put it in the middle of that opening there. Same with over here. I can kind of just shift this over. And I can kind of shift this over where it's roughly kind of halfway there. And this, I did a pretty good job. It's pretty close. I'm going to raise this up a little bit more. So it's, and that's it. That file is done. So your objective now for this last part of your Inventor tutorials is to now do these drawings. And again, you are to select any 3 of the parts in your project file for this 3D cube. And again, I expect to see the title block set up properly with the right labels in it. And then a neatly dimensioned and labeled views with a shaded isometric view for all 3 of those parts. And again, in the interest of allowing you guys to do a little self-exploration and learning yourself. On D2L under content, before you attempt to create a assembled view drawing and a exploded view drawing, you must watch the tutorial videos that I've provided in the content under Unit 6. And again, there's also a video there that includes how to do your title block as well. And I am most likely now, because I've now done it, I am going to also upload a copy of this video in the content. And this video itself will also be made available to you as soon as it finishes rendering itself. It'll be made available in our announcements for today. Okay, so I'm going to stop my recording now.